Alright, in this video we're going to be talking about joint and combined variation. So first let's review some direct and inverse variation things. You need to know that direct variation, to find the constant, we are looking for a ratio of y over x. For an inverse, we are looking to find the constant, we are looking for a product, which we are multiplying x and y together. The equation form of a direct variation is y equals k times x. The equation form of an inverse variation is y equals k over x. There are some examples given of different direct and inverse variations. To test for it, we do either the ratio or the product, check y over x in all of the order pairs. So as I mentioned before, if it doesn't apply to all of them, then it can't be direct or it can't be inverse. And then check the product for inverse, x times y, in all order pairs. For your graph, direct variation should be a line that goes through the origin. If it's a line but it doesn't go through the origin, it is not a direct variation. And then for your inverse, I don't believe I said this in the last lesson or video, but inverse variations, the shape they make is a hyperbola. Again, I mentioned that that's not something you absolutely need to know because you'll learn that more in Algebra 2. And then last thing that we're going to talk about review-wise, to solve for missing variables. So remember that the equation they give you right here, I'm sorry, not the equation, this part of this entire equation, sure. This is your constant k. So you are finding y over x and then setting it equal to another y over x. Whatever you get, the constant should equal the constant. And then for inverse variation, you should be multiplying the two together to find the constant. And the constant should be the same on both sides. So now that we've went over the review, we're just going to go through some examples really quickly to determine, are these direct, are they inverse, or not. So in these, we'll be given equations, tables, graphs, and we have to determine, are they direct variation, inverse variation, or neither. And then we need to write the equation for direct or inverse relationships if it's not already given to us. All right, so going through some of these examples. Number 1, if you need to, rewrite out your equations, y equals k over x, and this is inverse. Hopefully you were thinking that in your mind before I said that. And then y equals k times x, which then would be direct. That did not look like direct, but okay. So y equals 36 over x. A number over an x, that's your k over x, so that is your inverse. That is your inverse relationship, so we don't need to write the equation. Number 2, this has a constant in front, so it's like the kx, but it has a plus 1. Remember that our direct our direct variation has to have an intercept of 0. So if this 1 had not been here, it would have been direct, but because the 1 is there, this is a neither or neither, however you say that, case. Because this is clearly not inverse, it's not a number over x. It is a number times x, but it has a y-intercept of 1. Right? Moving on, number 3, if it is not in slope-intercept form or the y is not by itself, because it depends, solve for y. Get y by itself. So here I would divide both of these by 4. So I have y equals x over 4. Now you may be thinking this is a neither case, right? Because I'm not multiplying by k. But remember that this is really 1x, which means this fraction 1/4, I could rewrite this as y equals 1/4 times x. And these two things would be the exact same. So because of that, This would be a direct variation. It has a y-intercept of 0. It's a k times x situation. So that would be direct. And the equation we just wrote would be the direct relationship. Moving on to number 4. Now we have y times x. We need to get rid of x, so we're going to divide by x on both sides. If you're thinking that has to be an inverse, right? Because the x is in the denominator, you are correct. So this would be an inverse variation. Right? Now I'm going to start jumping around because some of these examples are more examples like the ones we just did. And I'm not going to do every single one because that would make this video extremely long. And we don't want that. Number 6. Again, we need to get y by itself. So we're going to multiply both sides by 2. So that would give us, these 2's would cancel, y equals, and I'm going to flip these 2. So I have 2x. I have y equals a k times an x. My y-intercept is 0, so this would be a direct variation. Jumping to number 9, I know I skipped a bunch. So now we're in a table. So to check whether this is direct or inverse, I'm going to look at the relationship between x and y. So remember, if you do y over x, that is for your direct. If you do y times x or x times y, that is for your inverse. But it has to work for all of them. So first, we're going to do 20 divided by 1.5. I'm doing this in my handheld calculator. So when I do that, I get 13.3 repeating. Let's keep going. 12 divided by 2.5, I get 4.8. So it's definitely not inverse. Eliminate that. I'm sorry. It's definitely not direct. I was dividing. Let's fix that. It's not direct. Okay, so then let's multiply. 1.5 times 20, we get 30. And let me just write some of these so we know in the video what exactly I did. So I got 13.3 repeating, and then 12 divided by 2.5, I got 4.8. So it's not diverse. I definitely just mixed up those two words. It's not direct. Oh my gosh. Anyway, and then 1.5 times 20, I'm just going to write it in between here. That would give me 30. 2.5 times 12, oh, that gives me 30. It might be inverse, but it has to work for everything. So don't just assume because it works for a couple. Wow, I definitely just typed in the wrong thing. 7.5, there we go, times 4. Still hitting 30, and we know that 5 times 6 equals 30 as well. So because everything equals 30 when we multiply them, this is inverse. Had I got like 5 times 5 in the last row, then this would have been in neither case. All right, the next one we're going to do is number 10. Same thing. So let's do 217 divided by 31. We get 7. 140 divided by 20, we get 7. So this is looking like it might be a direct. 119 divided by 17. And then 84 divided by 12. So because they all equaled 7, this is a direct variation. All right, we're going to do 11 and then jump to the next page. Same thing. So let's see, 36 divided by 3 is 12. 105 divided by 7 is 15, so it's not direct. All right, let's see. Now we're going to multiply 3 and 36. We get 108. 7 and 105. we get 735. So this is clearly a neither case because the direct isn't working and the inverse isn't working. But it could be, sorry, I meant to check that. It could be where you think it's going to be a direct, it's looking like it's going to be a direct for all of them, but then it's not for the very last one. Or it looks like it's going to be an inverse for all of them, but then it's not for the very last one. So always check all of them because one could not work. Also, double check your math because you could have accidentally made one not work as well, and we don't want that. All right, we're going to do just 2 more examples determining if they're direct or inverse as a review before we get into the meat of what this video actually is. For 15, I scrolled too far. If we're given a graph, here we're given this equation or this graph. We have to decide, is this direct, inverse, or neither? Hopefully, while you're watching this, you're screaming, maybe not screaming, or even yelling, it's direct. It is a line. It's going through the origin, so this has to be direct. If I had something like 16, hopefully in your mind, you're thinking neither, because yes, it is a line, but it's not going through the origin. For 17, if it makes this weird shape on both sides, that's a hyperbola. It has to be inverse every single time, no matter what the points are. 18, this graph should look familiar to you, but it'll look even more familiar to you when you learn quadratics either in this class or the next. But this is not a line and it's not a hyperbola, so this is neither. All right, so hopefully that was good review and you remember all of your direct and inverse variations, how they're the same, how they're different. Now we're going to get into joint variation slash combination variation, combined, there we go, combined variation. So we're going to start off with some of these. First, let's talk about what that even means. A joint or combined variation combines direct and inverse variation in more complicated relationships. So, if we have y varies directly, notice the wording, with the square of x. This would be y equals, varies directly means k times x, but in this case, instead of just having x, we have the square of x, which means x squared. If it said square root of x, then we would use the square root, but here it says the square of. So here we would write k times x squared. I just realized this should be over here, but same thing. There is a typo in this second one because it says the exact same thing. This should say inversely. Inversely. That doesn't look right, but I feel like it is. Okay, so if y varies inversely, remember that's your y equals k over x with the square of x. We know that part is still x squared. So we'd have y equals k over our x squared. Now, when we talk about jointly, something varies jointly, think about that as varies directly, but usually when it's varying jointly, it's more than just one variable. So usually when we say directly, it varies with the square of x, or it varies with y, or something, whatever. It varies with just one. So when we say jointly, it's still like directly, but it's multiple variables. So what do I mean by that? Z varies jointly, so think about that as directly. So that would be Z equals, we know we have jointly or directly, we know we need k times x, but in this case it's not just going to be x, Here we have with x and y. So instead of just putting x, we're going to put x and y. So when you have varies jointly, it's like we're multiplying everything they say together with k. But now, if we have something like varies jointly and inversely, how do we go about doing that? Break it down step by step. So we know it varies jointly with x and y. Do each part step by step. So do what you know first. You know this would look just like what we just wrote. Z equals kxy. That was not a good K. Don't know if that was better. Anyway. Then the second part of this says and inversely with w, which means if it just said inversely, so like let me go back up to the second example where it said y varies inversely, is what that was supposed to say, with the square of x, we needed to put x squared, in our denominator. So going back to our actual example, when I say inversely with w, that means I am now dividing by w. So all of this is going to be over w. So now let's take this a step further. Z varies directly, notice the wording, varies directly means with just one other variable, with x. So we have z equals kx, and inversely with the product of, so product, remember, is to multiply. The two things that are being multiplied are w and y. So inversely, we now need to divide, and we're dividing these two variables that are multiplying to each other. So w, y. Once you get the hang of this, it's not too bad, but it's definitely a process. You need to talk through everything, make sure you understand what goes where, because if you confuse something with something else, it's very easy to mistake jointly or indirectly or inversely and then put it in the wrong place and then solve it incorrectly. Right? And now we're going to do a few examples.
Alright, so we're going to start off with this example number 3. Variable y varies jointly with p and q. If y equals 144 when p equals 12 and q equals 8, find y when p equals 15 and q equals 25. So, as we mentioned before, varies jointly is like varying directly. So, let's set this up first. Y equals k times p, actually that's a capital P, times q. So this would be our equation. Then they give us some numbers. So we know y is 144. We don't know what k is. We do know that p is 12 and q is 8. So we can find k by solving this. Let me switch this around. This is still fine because the commutative property. And then divide both sides by 96. K equals 1.5. So now that I have what K is, I can go back and find Y and put in everything else. This is actually a capital Y. That's right. So Y equals 1.5 times P is now 15 and Q is now 25. So I would multiply 1.5 times 15 times 25 to get 562.5. So it's kind of like solving a regular direct variation problem. There's just more letters. For number 4, I was going to do number 4, but I think this is just an inversely. So we don't need to do that one. We can do 5. For 5, it says variable t varies directly with the square of m. The only reason why we're doing this one is because it has the square of m. So varies directly is going to tell us that t equals k times the square of m is m squared. We then know that this is 8 equals k times 2 to the second power, which we know is 4. And I'm going to switch these around. So then we can find k by dividing both sides by 4. And then we have to find t when m equals 4. So k is now 2, and m is 4, and we are going to square that. We can put that all into our calculator or do that all by hand. I'm just going to do it by hand. So 4 squared would become 16, and this would become 32. Right, let's try some others. Varies inversely, so I'm going to skip that one. Varies inversely, so I'm going to skip that one, because we've done those before. Here we have varies directly and inversely, so I really want to do this one. Alright, so I'm going to go through and I'm going to read it first. Video store rents DVDs, and the weekly total number varies directly with the total inventory, and varies inversely with the cost of each rental tape. The store in Acme, New York last week rented a total of 3,000, pretty sure that's supposed to say DVDs, anyway, when its inventory was 9,600 and the cost per rental was $2.40. If its inventory does not change, what would be the effect on the weekly total number of increasing the cost per rental to $3? So there's a bunch of stuff in here that's important. First, let's find some things that they said that we want to label as variables. The weekly total number, the total inventory, and the cost of each rental tape. So I'm going to label those as W for weekly total number, T for total inventory, wow, I can't talk today, and C for the cost of each rental tape. Then we know that the weekly total number varies directly. I should probably keep this color coded. Varies directly. So it's going to be some K with the T. And varies inversely, so we're not dividing, with the cost of each rental tape. Okay, so that would be our equation. Now we can change things around because we know some numbers. We know that the total number of DVDs, and that's what W is, and I should say total number of DVDs. So W is going to equal 3,000. We don't know what K is. We know the total inventory was 9,600. And the cost per rental was $2.40. So we can now solve for k and then figure out what that last part is. So to do that, you can do one of two things really. You could divide 9600 by 240, 2.40, and then solve for k, or you can get rid of the 2.4 first by multiplying on both sides. So that would give us 7200 or 7200 equals, I'm going to switch this around, 9600 k, and then I can divide. And I would get 0.75 equals k, or you can put it as a fraction, 3/4 equals k. So now that we know that information, we can go back. If its inventory does not change, so we know inventory is still 9600, we are looking for the weekly total number of DVDs. So we're still looking, I'm sorry, we weren't looking for W originally. Now we are looking for W. We know our K is 0.75. Our T is staying the same. And our cost is now increasing to $3. So we could multiply the top and then divide, or just put it all in at the same time. Put it in the calculators, whatever. And we would get that W equals 2,400, or the weekly total number of DVDs would be 2,400. So it looks like a lot because there's a lot more words and there's a lot going on, but it really is the same as we've been doing. We're just now doing it in two parts. Not really even different because we were already doing it in two parts. We were labeling, finding the equation, finding k, and then finding the whatever it asks us for. So we're still doing that. It's just now there's a varies directly and an inversely. Let's look at a couple more. So here, 4 and, we're going to do 4 and 5. A car stopping distance varies directly with the speed it travels and inversely with the friction value of the road surface. So already you know these things you need to put a variable to. Car's stopping distance, speed it travels, friction value of the road surface. So let's deal with that first. So let's say D is the car's stopping distance. Let's say, I really don't want to use S. We're going to use P. You can use S, just make sure you don't confuse it for a 5. It's going to be the speed it travels. And F is going to be the friction value of road surface. I can't spell it. It's fine. Okay. Then it says if a car takes 60 feet to stop, so that's the car's stopping distance. Oh, I skipped a step. Before we do that, let's put this together. So varies directly, D varies directly with the speed it travels and inversely with the friction value. So that would be our equation. Then you can start to put numbers in. We know a car takes 60 feet to stop at 32 miles per hour. That's the speed it travels. On a road whose friction value is 4. So let's find K first. Here, I'm going to simplify this first because I know that 32 divided by 4 is 8. And then I can divide both sides by 8. That's going to give me 7.5. So then it asks me what would the stopping distance, so I'm looking for D. I know K is 7.5. My speed it travels is now 60. And the road friction is now 2. Putting that into my calculator, I would get the distance would be 225, and here we were in feet, so we're going to continue that. Okay. And then the last one. A ball is dropped from a window of a building. The distance it falls varies directly with the square of the time it falls. So notice that there's only one here, but what it varies with is the square of. So not square root of, just square of. So I can say that the distance is something we need to have a variable for, as well as the square of the time it falls, or the time. So I can say D equals distance, and T equals time. So if we were to put that in an equation, the distance varies directly with the square of the time. So that would be T squared. Okay. Then putting everything in, we know a ball can fall 8 feet, so that's the distance, in 0.5 seconds, so that's the time. So we can solve for K. 0.5 squared gives us 0.25. Then I can divide both sides by 0.25. Now we get 32. Remember that 0.25 could be written as 1/4. So if I'm dividing by 1/4, I'm really multiplying by 4, which is why we got a bigger number. And then putting this back in, we're looking for how far, so we're looking for distance. Will it fall if it takes 2.5 seconds? So we know our K value is 32. We know our time is now 2.5, but we're still squaring it. So we're going to multiply 32 by 2.5 squared. And our distance should be 200 feet. So once you get the hang of this, it's not terribly bad. You just have to read the wording and define variables, put that into an equation, solve for the missing variable, and then use that to solve for the other missing variable. So now use this time to go over some more examples and let me know if you have any